In question 10, points A, B, and C lie on the circumference of a circle with center D. We have to show that angle ABC equals to 90 degrees. Now, to show that angle ABC is equals to 90 degrees, so if this is a right angle, it means that the gradient of AB and the gradient of BC will be a negative reciprocal of each other. So in the first step, finding the gradient of AB, that will be equals to y2 minus y1. So that will be 0 minus 3 upon 3 minus minus 2. So that will be equals to minus 3 upon positive 5. And now finding the gradient of BC. So the gradient of BC will be equals to 5 minus 0 divided by 6 minus 3. So that is equals to 5 upon 6 minus 3 is 3. So as the gradients are negative reciprocals of each other, it means that the angle is right angle, or we can show through another working, that is, if you multiply the two gradients and the answer is -1, the two lines will be perpendicular. So multiplying the gradients, when we multiply 5 and 5 will cancel, 3 and 3 will cancel. So this is equals to -1, which shows that the lines are perpendicular to each other. In part B, it is asking us to state the coordinates of D. Now, as the center is D and ABC is 90, so to understand this, let's say this is a circle and ABC is a right angle. Now, in a circle, we know that if we have a diameter and the two ends are meeting at the circumference, so let's say these two lines are meeting at the circumference, this makes a right angle. And if this makes a right angle and this is the diameter, it means this will be the center. Now, as angle ABC was a right angle, it means AC is the diameter, which means to find the center, we'll find the midpoint of AC. So finding the midpoint of AC, the midpoint is given by x1 plus x2 upon 2. So that will become -2 plus 6 upon 2 and 3 plus 5 upon 2. So -6 plus 2 is 4. 4 upon 2 will become 2 and 3 plus 5 is 8. So 8 upon 2 will become 4. So the coordinates of the center of the circle, which are basically the midpoint of AC, will be 2, 4. In part C, we have to find an equation of the circle. Now, the equation of a circle, the general formula is given by x minus a whole squared plus y minus b whole squared equals to r squared, where a comma b are just coordinates of the center of the circle. Now, we already have the coordinates of the center of the circle. To find the radius, we'll find the length of AC and then divide the answer by 2. So the point A is -2, 3, and the point C was given as 6, 5. So finding the distance of AC, so that will become, we'll apply the formula x2 minus x1 whole squared. So that will become 6 minus -2 whole squared plus y2 minus y1. So that will become 5 minus 3 whole squared. Simplifying this, 6 plus 2 whole squared is 64. So this will become 64 and 5 minus 3 is 2. So that will become +2, which is equal to 68. So the distance will be square root of 68 and the radius will be half of this. So for the radius, we will write square root of 68 divided by 2. Now writing the equation of the circle, so that will become x minus a whole squared. So the x coordinate was of the center was 2. So that will be x minus 2 whole squared plus y minus the y coordinate of the center was 4. And this is square root of 68 upon 2. And this will be whole squared up here. Simplifying this, we can write this as x minus 2 whole squared plus y minus 4 whole squared equals to, so square root will cancel with the whole square. So that will become 68 upon 4. Simplifying 68 upon 4, that is equals to 17. So the final answer for the equation of the circle will be x minus 2 whole squared plus y minus 4 whole squared equals to 17. In part D, it says that the point E lies on the circumference of the circle such that BE is a diameter. We have to find an equation of the tangent to the circle. Now, to understand this type of question, it is better if we can draw a circle up here. Now, let's say the point B was up here and it had coordinates the coordinates of B were 3, 0. We already know that the center of the circle has coordinates 2, 4. So this is the center, and BE is a diameter. So making a straight line, and this point will be E up here. And it says that we have to find the equation of the tangent to the circle at E. So first, making a tangent to the circle, we know that a tangent is basically perpendicular to the radius or the diameter. So to find the equation of this tangent, we need the gradient and a point on this line. Now we already know that the center will be the midpoint, and it has coordinates 2, 4. So we can first find the gradient of the line BE by finding the gradient of B and the center point. So the gradient of the line BE will be equal to gradient of the line BC, as they are on the same line. So finding first the gradient of BC, that will be equals to y2 minus y1, which is 4 minus 0 divided by x2 minus x1, that is 2 minus 3, which will be equals to 4 upon minus 1, which is equals to minus 4. Now, the gradient of the tangent, so the gradient of the tangent will be a negative reciprocal, which is positive 1 upon 4. Once we have the gradient, now to find a point on the line, as C is the midpoint, so we can apply the midpoint formula to find the coordinates of E. So the midpoint is 2, 4. The formula for midpoint is x1 plus x2. So let's write the coordinates as x and y. So this will become x plus 3 upon 2, y plus 0 upon 2. So equating 2 with x plus 3 upon 2, so that will become 2 equals to x plus 3 upon 2. Cross multiplying, we'll get x equals to 4 minus 3, which is 1. And equating 4 equals to y plus 0 upon 2. So 2 times 4 will be 8. So y will be equals to 8. So the coordinates of E will now be 1, 8. Once we have the coordinates, we can now write the equation as y minus y1 is equals to m, which is 1 upon 4 into x minus x1, which is 1. We can simplify this to write it as 4y minus 32 equals to x minus 1. And we can simplify to write it as 4y is equals to x minus 1 plus 32. So the final answer will be 4y is equals to x plus 31 for the equation of the tangent.